So, the first presentation, my name, as Alice said, is Robbe, and I will be talking about how to use AI and more directly how to use demand forecasting for the transportation sector to create a more sustainable future in a way. So, to give a short overview, I will start off with a small introduction and then go into three case studies which are more in depth on how it could be applied and how it would look like to you in the world, essentially. So first and foremost, why the transportation sector? Well, 17% of the global greenhouse gas emission comes from the transportation sector alone. So that's a massive number. You can also see it, 7.3 billion metric tons of CO2 every year. This is a lot. This needs to go down. So that's why I decided to take this topic and to talk about it, basically. So maybe first, what is demand forecasting? Very simple. It's basically based on historical data for the most part. You will try to predict demand or basically predict demand into the future. That way you can, as a company or a business, use it to increase customer experience or enhance customer experience to make it better, improve resource optimization, and reduce the carbon footprint as well, because you can improve resource management and so on and so on. Knowing beforehand how many people will arrive for a specific bus, etc., can help a lot. So beforehand how many people will arrive for a specific bus, etc., can help a lot. So how we see it at Radix is not by just replacing anyone with AI and then saying call it a day. It's a bit stupid in my opinion, but we as Radix see it more as a co-pilot and will give a future prediction on, for example, the amount of people taking the train, and then an expert can take it into account and maybe see, okay, we are even expecting more than we were accounting for, so maybe we should increase the amount of train wagons for this specific peak hour train. Or we see that, for example, there are buses with no people on. They don't need to drive out, they don't need to go out, essentially. And then the expert can give a final decision on what to do based on our information we provide. So that brings us to the first case study of this, like predicting the expected occupancy. It's the mainstream one. It's basically predicting how many people are going to be on a specific type of transportation. So by knowing in advance how many people you are, I already gave two examples with empty buses not needing to go out or trains being overcrowded, which also leads to less nice experience for us. By better knowing in forehand what's going to happen, scheduling managers can take it into account, can change their schedule based on the output of the AI, and that way create a better schedule, essentially, providing more trains where needed and less traffic where not needed, so that during peak hours everything is more nice for us, and during off-peak hours there's less waste, less not useful transportation. So then the second case study or way to apply this basically is dynamic pricing. So you're probably thinking of the opposite one, where there is a lot of demand, we're going to increase the prices. That is something that companies like Uber and Lyft do a lot, but that's not the way I would want to tackle this, because that's essentially the opposite of what I want to achieve. What I want to do is basically encourage people to take a different approach. Instead of taking the car, we know it's an off-peak period. People will be inclined to take the car because it's not busy, it's easy, but we can provide a discount during these off-peak hours because we know in advance the demand. We know it will be off-peak, not many people will be taking our trains. We can encourage them, or the bus, we can encourage them to actually consider us by reducing price to basically provide a better alternative, and in that way also reduce congestion by the massive amount of traffic that comes to Brussels, for example, every day. Which brings me to the last topic, resource allocation. It's similar to the first one, but the focus is a bit different. Instead of thinking about train wagons, amount of buses, you can also apply it in other use cases. For example, at Brussels Airport, this is actually a project I worked on and I'm proud to have worked on it, is we try to predict the amount of PRM people, so that's people with reduced mobility, that are going to arrive at the airport. That way we know in advance, okay, so many people are going to go to the airport and they will need help to get to their plane. It's the same for a train station. So many people are going to come in, they need help to get on the train. We need people, staff to assist them. We need resources like wheelchairs or crutches or whatever to help them on board. We want to be able to provide such a service to all of these people. For them, it's much nicer, and also for everyone else, essentially as well. So that way a resource manager can take into account, okay, in the future we see a peak around this hour, we need to gather more staff so that we are able to provide assistance where needed, essentially. And that already brings me to the conclusion of my presentation. I just picked 3 case studies, but you can apply the idea to a lot more, I think. And the idea is just to basically help AI empower people to improve things like resource efficiency, reducing waste by making better decisions, improving scheduling, and so on, and all together with the same goal, basically creating a more sustainable future. And with that, thank you.